This is for General Maths Specialist, Thursday the 13th of September, period 5. You're there in E21, but of course I'm at the Nova watching
questions? Can you make it sound blacker?
But of course I'm there and you're not. You're doing some So remember that displacement is a vector. It has a direction and a magnitude. Velocity is a vector and acceleration is a vector. Positive means it's moving to the right. Negative means it's moving to the left, or its displacement is to the right and its displacement is to the left. We use S or X for displacement. We use V for velocity. We use A for acceleration. And all of them are to do with time. So often this will be referred to as S of t, or X of t, or V of t, or A of t, because the independent variable is t. Velocity is the derivative of displacement, and acceleration is the derivative of velocity. Okay, looking at 14.1, question number 8. The position of an object is given by x equals minus t squared plus 2t plus 8, where x is the displacement from a fixed object at time t. So, for my displacement, it's actually going to be x against t. X is no longer the independent variable, the horizontal axis. X is now the y-axis. Sometimes the book will use S instead of X. Sometimes it will use X. In this particular example, the position has been defined by the rule x equals minus t squared plus 2t plus 3. So we have x in this particular case. Part A says sketch the position time graph from 0 to 8. Okay, so I've got to sketch this parabola. So what have I got? I've got minus t squared plus 2t plus 3. I'd like to factorise minus t and t, obviously 3 and 1, where the 3 goes on the top and the 1 goes down the bottom, so that I get a positive 2t, which means I have x-intercepts at t equals negative 1 and t equals 3, and of course I'll get rid of that one because I'm only drawing it from 0 to 8. My y-intercept is 3, so I'm going to start here at 3, and I need to know what 8 is, and I know that at 3 I have an x-intercept, so obviously I'm going to have some sort of graph that goes down here like this. I'd like to find out what maybe x of 8 looks like, and that's going to be minus 8 squared plus 2 times 8 plus 3, negative 64 plus 16 plus 3, negative 64 plus 19 is going to be negative 45. So I might graph that again a little bit over here. I need to go from 0 to 3 to negative 45 across to 8, and I'm going to have a point down here, there, and it's going to go through at 3, so we're going to look like that with my parabola, where that's 8 and negative 45, that's 3, and I need to find that turning point, don't I? I know that my x-intercepts would have been at negative 1 and also at 3. Dead middle is 1. Therefore, turning point will be at 1. And if I sub 1 into here, I get negative 1 plus 2 plus 3, which is 4. So there's my graph of x against t. A y-intercept, which is really the x-intercept of 3, cut through at 3, height of 1 and 4, and it goes down there at 8 and negative 45. So that's part A. Part B says calculate the initial velocity. To calculate the initial velocity, I know that x equals minus t squared plus 2t plus 3. Initial velocity, well, velocity is dx dt. So if x equals minus t squared plus 2t plus 3, dx dt will equal minus 2t plus 2, and at t equals 0, because at initial, that's when I start, therefore t must equal 0, velocity is going to equal 2 meters per second. Part C says find when and where the velocity is equal to 0. When and where, therefore t equals x equals, that's what when and where means, v equals 0. I have an expression for velocity, it's minus 2t plus 2. So v equals 0 when 0 equals minus 2t plus 2, minus 2 divided by 2 equals t, t equals, 1. So at t equals 1, so it's going to be 0 at t equals 1, and I know from my graph that x equals 4 when t equals 1. So there's the two answers for part C. Find D. Find the average velocity in the first 4 seconds and the average speed in the first 3 seconds. Average velocity in the first 4 seconds. Average velocity will equal the velocity at time 0, at term 4 minus the velocity at time 0 divided by 4, or y2 minus y1 over x2 minus x1. I know that the velocity equals minus 2t plus 2, so the velocity at time 4 will equal minus 2 times 4 plus 2, minus 8 plus 2, minus 6. And the velocity at time 0 is the initial velocity, which I know is equal to 2, over 4 is minus 8 over 4 equals minus 2 meters per second, is the average velocity over the first 4 seconds. And part E asks, find the average speed in the first 3 seconds. Average speed is total distance travelled over time. So for the first 3 seconds, I need to find out how far did it travel in the first 3 seconds, divided by 3. I have a graph, and my graph told me that for the first 3 seconds it did this. It went from 3 up to 4, then back to 0. It went from 3 up to 4, back to 0. It went up 1 and down 4, a total distance of 5 over 3 meters per second. And that is the example that I'll do out of 14.1.